Alright, so today we're going to start on trigonometry, specifically where we're going to be working with trig ratios and being able to find missing sides with pieces we're given. A couple of things, knowing that trigonometry specifically is a study of right triangles, and that's helpful for what we need it for because most of the stuff we're using doesn't work unless it's a right triangle. We're not going to be doing any trick questions or anything like that today that you've got give you all the pieces, but if you weren't paying attention that it's not a right triangle, that it doesn't work. We're not worried about that right now. Since I'm gone, we're definitely worried about just how do we set it up. Hopefully yesterday's Pythagorean theorem was really easy for you. I know there was some challenging word problems on the one, but if you watch that video all the way through, I helped you set all of those up. So hopefully you did that all right. Do remember to turn in your work. If you didn't do that yesterday, I did look and it appeared that I had a large number of them, but just in case you didn't get finished, you can turn that in today. So let's dive in trig functions. First thing we need to be able to do is to be able to label triangles. Now, if you've noticed, I've got a lot of things opposite, adjacent, hypotenuse here. All of those refer to an angle we're given. Now, the hypotenuse never changes. Hypotenuse always refers to that side across from the right angle. Always. Doesn't matter where the triangle's turned. Doesn't matter which angle we're talking about. Hypotenuse always is across from the right angle. So it never moves. Now the challenge with opposite and adjacent is those are terms that it depends on where you start. So give you the example, if I say someone is across from me, well, that depends on where I'm standing, depends on where they are, right? So if I'm looking at this angle right here, my opposite side is going to be across from it, is going to be this side here. So I'll have opposite, which makes adjacent, if you remember that term, adjacent means beside or touching. So that's touching this angle, that's the adjacent side. Now, we know that this is not the adjacent side, even though it's also touching this angle, it is not the adjacent side because it is across from the right angle. It is always the hypotenuse. It is never an adjacent side. And that's one of the things that a lot of people mess up when they start trying to name these things. So please make sure that you never, ever call that the adjacent side. It's always the hypotenuse. That never changes. Now, if, get rid of those for a moment. Alright, so I've got rid of those other ones. The reason I didn't get rid of hypotenuse is because, as I said, it never changes. It never moves. Never, ever moves. So please do not move it. Now, if I were to change to this angle over here, now my reference points have changed. My opposite and adjacent sides have changed. So it matters where the angles are. So opposite is still going to be across the triangle from that angle. So opposite is going to be over here. And my adjacent side is going to be the one that's touching the angle, the one that's next to, beside, touching. Those are the words. It's what adjacent means. And since this one's touching the angle and it's not the hypotenuse, that has to be the adjacent side. So the hypotenuse never moves, but opposite and adjacent is just depends on which angle you're given. Opposite's always across the triangle from it, not touching that angle. Adjacent is always right next to it, touching that angle. Alright? So if I'm looking at these, this one right here gave us this angle, so we're looking at this one. So if I have that over here is my opposite side. Again, because it's across the triangle from it, not touching that angle. That makes this side the adjacent side. And this one is still the hypotenuse. That never moves. So again, same triangle, different angle this time. Red and blue, so it's a little easier to tell which one's which. So this one, that side's still the hypotenuse because it doesn't move ever. Across the triangle, I have the opposite side. So opposite. And because it's touching the angle, it's right beside the angle, it's right up next to it. This is my adjacent angle. Right? If you can't figure that part out, the rest of this is not possible. Alright? And now I'm fine if you're not understanding how the whole opposite adjacent works. If you have a friend in the class that understands it and is willing to explain it to you, I'm fine with that. Don't want you going through the whole thing with a partner, but if you're having trouble understanding the opposite and adjacent, you can't do the rest of this without understanding opposite and adjacent. Opposite is across from it, not touching it. Adjacent is beside it and touching it. That's an important skill, and I know some of you are probably bored to death with that already, and if that's the case, then hopefully you're skipping along on there if you understand it. This is for the people that are having trouble with that because for some reason opposite and adjacent messes a few people up. Don't know why, but it does. These are my trig ratios. Now, one of those worksheets that I gave you, that first one, there's a guided practice that has these on one of the pages. And if you're looking at it, a lot of these notes are written on there already. You may want to write some of these things down on a separate sheet of paper as well, simply because we're going to be doing more of this stuff before you get that paper back. And if you don't have these somewhere, then you're not going to be able to look back on them later. Now, we're going to look at this so katoa over here. You may or may not have heard that before, but whether you have or not, we're going to learn what that means, but we're also going to learn something that's going to help us remember it a little bit. So these ratios, when I use the sine ratio is when I have the opposite side and the hypotenuse. Okay, the order and where all this goes matters, but we're going to do that in just for a second. First, we're going to learn when to use these things. So I use the sine ratio when I have an opposite side and a hypotenuse side from an angle. Alright, all of these refer to that angle I'm looking at, just like the other ones I just did, labeling opposite and adjacent and hypotenuse. So when I have a set of sides, and I have the opposite side and I have the hypotenuse, I'm going to use the sine ratio. When I have an angle and I have two sides, I have the adjacent side and the hypotenuse, I'm going to use the cosine ratio. And when I have the opposite side and the adjacent side, I'm going to use the tangent ratio. That's what those are called: sine, cosine, and tangent. Alright. So katoa. What that comes out to be, that is sine opposite hypotenuse. Sine opposite hypotenuse. So. Okay. Ca, not so co, so ca, C-A-H, cosine adjacent hypotenuse. Ca. And then toa, tangent opposite adjacent. We say it that way to not only help us remember what we use in each ratio, but also the order. Because I've got sine opposite over hypotenuse. I always set it up opposite over hypotenuse. That never changes. If I've got the opposite and hypotenuse sides, I set it up with the sine ratio, and I do opposite over hypotenuse. If I have adjacent and hypotenuse sides, I'm going to use my cosine ratio, and I always set it up adjacent over hypotenuse. I'm always going to be these orders. These orders right here for sine, cosine, and tangent do not change. They're there forever. Now, I told you that we have SOHCAHTOA. That's one thing that people remember, but there's some people have trouble remembering SOHCAHTOA or have trouble remembering the order on those, because the problem with SOHCAHTOA is that people misspell it when they go to write it down. So there is a phrase that sometimes we'll use to help us remember the order of things, and here it is. So here it is, and sometimes people think this is a little silly, but they are also often surprised how well they're able to remember it. So some old hippie caught another hippie tripping on apples. Now, that's the PG version. You could substitute something else that they're tripping on if you really wanted to, as long as it begins with the letter A and you can say it out loud in public. So, some old hippie, S-O-H, so, sine opposite hypotenuse. Caught another hippie, ca, C-A-H, cosine adjacent hypotenuse. Tripping on apples, toa, T-O-A, tangent opposite adjacent. Alright? So that's a little something, may help you remember that, because you're not given the trig ratios anywhere on any test you take ever. They're expected for you to memorize those. Alright? We're going to use them a bunch today, but you are going to have to memorize those on your own. So we're going to do some practice with this. Alright? When you do sine, cosine, tangent, you do these trig ratios, there's always going to be a reference angle. Sometimes they label the reference angle like A, B, or C. Sometimes they label an angle. They have it as one of our marks that we're used to seeing the angle arches. Or sometimes they'll give us a degree measurement. And so something along the lines of the measure of angle A there would be 35 degrees. So we would be looking for sine of 35 degrees. And we're going to see what that looks like in just a minute. Right now we're going to use our reference for our angle. So, first one, it wants angle A, and it wants us to use the sine ratio. So that's some old hippie, opposite hypotenuse. Sine A is opposite over hypotenuse. So my opposite side from A, and sometimes it helps to circle your reference angle. Alright? Really knowing where you start. So I'm starting at A. So some old hippie. So old opposite. It's the one not touching that angle. So that's a hypotenuse. That's the side touching A. This is the one not touching A. That's my opposite side. It goes on top of my ratio. So I'm going to set it up 3 over my hypotenuse. Some old hippie. H, called as the hypotenuse. Hypotenuse on this one is 5. I know it's 5 because it's the one that's not touching the right angle. It's all the way across from it. All right? Hypotenuse is always there. So in this one, the hypotenuse is 5. So the sine of A equals 3 over 5. And unless they tell us otherwise, leaving it as 305 is acceptable. All right? Unless they're telling you to solve for something, just leave it as 3 over 5 for an initial setup. That's fine. So remember, hypotenuse, it never changes. I can't label opposite and adjacent on this one because it changes depending on your angle that you're using. So next it's wanting us to use cosine of A. Alright? So I'm going to hide the other one. And now we're talking about cosine of A. Let's change color since we're doing a new one here. Cosine of A. Remember, cosine, call it another hippie. Alright? Ca, C-A-H. So in this time, we're still using our hypotenuse, but this time we're using the adjacent side instead. So the cosine of A is going to be the adjacent side, 4, over the hypotenuse, which didn't change, is still 5. The setup on these ratios is real simple. It's real simple. What people tend to get confused on is the solving part, and we're going to get to that, but one thing at a time. So we go to tangent of A. Tangent of A. And tangent A, tripping on apples, or something else if you just really feel the need. Tripping on apples, TOA, tangent, opposite, adjacent. So you notice in tangent, you don't use the hypotenuse at all. You use the two other sides. You use opposite over adjacent, and it's important they go that order. So still talking about from angle A, we haven't moved, so the opposite side is still 3. So I'm going to write 3 over my adjacent side, 4. Alright? So, changing my reference angle. If I change my reference angle from A to B, there we go, from A to B, my opposite and adjacent sides have now moved. B is here, 4 is my opposite side, 3 is my adjacent side because it's touching B. Opposite's across from B, it's not touching it. Alright? So if I go to set up those ratios again, I want sine of B. Some old hippie, sine, some old hippie. OH, opposite hypotenuse. So opposite side, 4 over the hypotenuse, which has not changed, 5. So when I change my reference angle, which angle I'm starting at, my sine ratio changes because I was using different sides this time. Alright? So sine from reference angle B, opposite over hypotenuse, 4 over 5. Now I've got cosine of B. So again, using B as my reference angle there. Cosine B. Caught another hippie. C-A-H. Okay, ca. So ca, toa. Caught another hippie. So adjacent side over hypotenuse. Adjacent's 3. Hypotenuse has not changed with 5. So my cosine ratio is 3 over 5. Right? And last, my tangent ratio tripping on apples, T-O-A, TOA. So that's the tangent is opposite over adjacent. So opposite over adjacent. I'm going to have 4 over 3. Alright. I'm allowed to have improper fractions on this. What's important is that I have everything in the correct order. The order does matter on all of these. So now we have x and y as our reference angle. We're going to do a couple of those real quick, just setting up our ratio. Alright. Alright, so we're going to do some of these ratios again. The difference on this one, if you'll notice from the last triangle, is I only have 2 sides labeled here. So that's going to mix things up for us a little bit depending on which of our ratios we're going to use. We may have to use a variable for that other side because it's an unknown, and that's fine. In this case, we're not going to use x or y because they're already used to show angles. But we could use another letter. We'll use z for this instance if we have to use a side. Now, if we don't have to use that side, we don't have to worry about a variable. But we will on some of these ratios here. So let's go through. Sine, some old hippie. So that's S-O-H. That's opposite over hypotenuse. Now, my reference angle in this one is x. Opposite over hypotenuse. So x, my opposite side's the one not touching it. It's my unlabeled side. So I am going to have to use it as z on this one. So I have an unknown length, so opposite length is z over hypotenuse. Now my hypotenuse never ever ever changes. It's always across from the right angle. So in this case 13. And that's going to be fine because we're actually going to be doing some of those later that have a side that isn't labeled, and we're actually going to be figuring out what that side is, but we're not there yet. Just know that that's coming. So it's fine to have that missing side in there. Cosine x. Alright? So x, again, telling us reference angle. We're talking about the angle x there. Caught another hippie. That's ca. Caught another hippie. C-A-H. Adjacent hypotenuse. So I'm using the adjacent side, which I have. It's 5. Over the hypotenuse, which did not change, which is 13. Alright. Tangent of angle x. So again, x is my reference angle, going back to x. So tangent is opposite over adjacent, so that's the TOA, or the tripping on apples, T-O-A. So tangent x, T-O-A, opposite z over a adjacent, which is 5. So I'm going to have z over 5 for tangent of x. Alright. Again, it's one of those, it's fine to have a variable for a side on one of these. Not a problem at all. So now I'm going to be using reference angle y over here, so I'm going to be using that angle. So things are going to change a little bit again. Mainly just the order it's in, because now my opposite and adjacent sides have moved. And again, they move in reference to my reference angle. So now my opposite side is across from it, is 5. My adjacent side is my unknown side, which I'm going to call z for right now. The hypotenuse did not move, nor will it ever move. So sine of y, some old hippie, S-O-H, right? Opposite over hypotenuse. As I said, my opposite side for this one is 5. Over the hypotenuse, which has not changed, is 13. Cosine, caught another hippie, C-A-H, right? Adjacent over hypotenuse. My adjacent side is my unknown side on this one, so I'm going to say z over hypotenuse, z over 13. Tangent, it's that T, TOA, tripping on apples, TOA. So that's opposite over adjacent. And opposite is the one not touching the side at all, or excuse me, my reference angle at all. And my adjacent side, in this case, is my unknown. So opposite over adjacent, 5 over z. Right? And that's the basic setup. Sometimes you're going to have a side that you don't know, and it's fine. Most of the time, if that's the case, they're going to give you a variable for it. They're not going to make you create one. All right. So there's some things real quick we can do on our calculator with evaluating some of these angles. Some of the angles we have, your calculator can figure all this stuff out. All right. So if they just want the sine of an angle measurement, like sine of 36, if they want the cosine of 55, they want tangent of 71, they've got these things in, and all they want is the value of those. Your calculator will do it for you. So first thing we need to do is hit that mode button. All right. Mode button, if you look up here on your calculator, is right there beside the second button. Find that mode button. You need to look for the words radians and degrees. Make sure the word degrees is highlighted. If it's not, move the cursor till it's sitting over the word degrees and hit enter. And it should be flashing and it should be highlighted then. And then you can go back to your home screen. If it is in the word, the word radians is highlighted, you're going to get the wrong answer. All right. Now we're not going to deal with radians right now. We'll deal with radians later. That's why you have both on your calculators, because you've got think of it as a unit, like we would have centimeters or meters, things like that. You've got radians and degrees. Those are labels. Those are units. In this case, we're dealing with degrees. We got 36 degrees there. So we want to make sure the degrees is highlighted. So once you've checked, you hit mode, and you move over to degrees, and you'll be good. Then all you have to do is hit the sine button on your calculator, which is right there, right, SIN, and it will pop up SIN with the opening parentheses. Type in 36 and close your parentheses. Don't try to type the degree symbol. That's why we put our calculator in degrees. Right? That was why we did that first. When you type that in your calculator, again, it's sine and then 36, and you should get equals 0.58, and it's 7, but I'm rounding it to 8. All right, it's actually a very long decimal. I'm rounding it to 0.588. If you instead got negative 0.991, etc., on and on, you have your calculator in the wrong mode. You need to go back to mode, go to degrees, and highlight. All right. We do cosine of 55, so we're going to hit the cosine button, which on your calculator is right beside the sine button. We're going to hit cosine 55, close your parentheses. Again, we don't need the degree symbol, and it's going to equal 0.574. Generally, the third decimal place is enough to round to, unless you're told to go to a different one. That's always the rule. You know, go to about the third decimal, go to the third decimal place unless you're told otherwise. Now, tangent, same thing. Tangent's right there with it. It's right beside the cosine button. My laser pointer will work. There we go. It's right beside the cosine button. And we're going to hit tangent, and that's 71 on there in case you can't read that. Tangent is 71 degrees. So you get tan, 71, close your parentheses. You're going to see it equals 2.904. You know, tangent works out a little different, and it often does, and it's because we don't use our hypotenuse in it. Alright? Good. Calculator one is real easy. It's just punch it in. That's all there is to it. Now we're going to start putting this stuff together. Alright? We're going to start using these ratios to find missing sides. I know this is kind of a long lesson, but this is important, me going through. Remember, if you, especially some of those examples I did, if you understood them and want to skip some of them, that's fine. Hopefully you have, but you know, it's going through this here. We need to figure out first our reference angle, and we need to figure out opposite and adjacent for that reference angle. So our reference angle on this one is 40 degrees. I have opposite across, adjacent's down here. It's not labeled. And it's telling us to find x. So we have to pick which ratio we're going to use this time. It doesn't tell us which one. We have to pick which one based on the sides we have. We've got the opposite side. We've got the hypotenuse. So that's opposite, hypotenuse, old hippie. So we're going to use sine. I'm going to use sine of my reference angle. So in this case, it's sine of 40 degrees equals, I'm going to set up my ratio, opposite over hypotenuse. Opposite is x, remember, because it's across from the angle. So x over hypotenuse, 10. And that's how you set up a ratio. Now, hopefully that part wasn't a challenge after all we went through there. You were able to set it up. You've not seen it writing it as sine of a reference angle like this before. But when you use degrees, we go ahead and put those parentheses around it, use the degree symbol. So we'll say sine of 40 degrees equals, and then just set up your ratio like we did on all those other ones. Now, what we're going to do now is actually try to solve for x. There's some things that are important here. Sine of 40 is a number all by itself. Sine of 40 is a number. It's an entity all by itself. It's combined. It's not separate. Don't ever try to break those up. Never, ever, ever break those up. They're always together. So if I have to move that for some reason, because I'm solving an equation here, if I have to move that for some reason, I move the whole thing. Never just one piece. We're going to start with this easy one here, where we don't have to move sine of 40. Alright, so what we're going to do is we're going to try to get x by itself. Now, with a normal equation, if we had another variable over here, or we just had 40, and we're trying to get x by itself, we see the x is being divided by 10. So, to move that, we would multiply both sides by 10. Let me change color so it's easier for you to see what I'm doing here. Times 10 times 10. I do the same thing just like I was solving any other equation. Now I have, I'm going to zoom in here a little bit so I got a little more room. I now have 10 times sine of 40 degrees equals x. Now, depending on what you're asked to do, the 10 times the sine of 40 is your answer, or if they're wanting it in decimal form, all you have to do is type that in your calculator. 10 times the sine button, 40, close your parentheses, equals, and you'll get your answer. Most of the time, these do not come out to be pretty numbers, but every once in a while they do. So you do 10 times sine of 40. This is one of those instances it does not come out as a pretty number. So in this case, we're going to go third decimal place and round. So 6.42, and it's a 7, but I look at the next digit, which is an 8, which means I move it up. Equals x. And as far as that rounding rule goes, there's a poster on my wall there to help you remember rounding. There's also that 5 or more, raise the score, 4 or less, let it rest. You may have heard that before. So when you go to do this, most of the time you're going to be asked to give an answer that's a decimal like this. If I can get my laser pointer to work with me here, there we go. Give a decimal form like this. But if it doesn't specify, or I don't specify, feel free to use this right here. It's the exact answer. We always like exact answers when we can. So let me zoom back out here so that I can see my next problem. So the first thing we're going to do is we're going to determine what ratio to use. So 61 is my reference angle. And I know that I have the opposite side, the one across from it, and the adjacent. All right. Anytime I see that I'm missing the hypotenuse, that it's gone, I'm going to be using tangent because I have opposite and adjacent. That's the TOA, tripping on apples. And the first thing I'm going to do is I'm going to start by setting up my ratio. So I already said I know I'm going to be using tangent of my reference angle, which is 61 degrees. Alright. So, I now have to set up the actual ratio of sides. So, opposite over adjacent. Opposite is x, adjacent is 5. And again, I've got that number on the bottom. I'm trying to get x by itself. So what I'm going to do, since I'm dividing x by 5, I'm going to multiply by 5 to get rid of it. So those cancel out there, and I'm left with 5 times tangent of 61 degrees equals x. Now, again, depending on what you're asked to do, we could potentially leave it like that and not have to worry about it. But I'm wanting a decimal form on there so that I know what's going on. So I'm going to do 5 times the tangent of 61 and close my parentheses and hit enter. And I'm going to get 9.020 equals x. And again, that's rounded to the third decimal place. So since we've rounded to the third decimal place, we don't actually need that last 0 and we can get rid of it. But I put it on there to show you again, I did go to that third decimal place. It does round off and is still a 0. If it didn't ask for the length on there, you could potentially leave it there. Most of the time, what you're going to be asked to find is to find this decimal, to go ahead and punch it in your calculator. Now, I'm going to pause here for a second to explain. When you're solving this, you really have to pay attention to what you have and what you're doing here. So many times when I've done two examples like this, they go, oh, all you do is multiply by the number you have on both sides, and that's your answer. And no, you can't treat it that way. You do have to treat it like an equation. And just like every other equation, we don't say we solve it exact same way every time. You got to look at what's going on. You got to think a little bit each time we're doing this. So let's do a couple of examples going through these. I know these are a lot of notes. I know this is a long video. Thank you for staying with me. So we've got, setting this up here, we've got reference angle of 40. We have our opposite side and we have our hypotenuse. Opposite over a hypotenuse. Some old hippie, so that's sine. Let's zoom in a little bit so I've got a little more room. So I've got sine of my reference angle, sine of 40 degrees, equals, and now I set up my ratio, opposite over hypotenuse, x over 10. So in this one, I'm trying to get x by itself again. So x is being divided by 10, so I multiply by 10 to get rid of it. That cancels out, so 10 times the sine of 40 degrees equals x. Punch that in your handy dandy calculator and you do 10 times the sine of 40, which gets me in this case 6.428, and that's my answer on that one. So let's go to number 2 down here. So again, look at my reference angle, which is 61. I have the opposite side, I have the adjacent side. So I'm going to set that up as tangent of my reference angle, which is 61 degrees, equals opposite over adjacent. Tripping on apples. I got x over 5. Just like the other one, I'm going to, x is divided by 5, so I'm going to multiply by 5. I promise this changes up here in just a minute, so you got to pay attention. 5 times the tangent of 61 degrees equals x. And you type that in your calculator. Alright? Trying to work on the solving part of this because it's the difficult part. Punching that in your calculator, never have people really have trouble with that. I mean, it's just type it in. So again, we're going to start by finding our reference angle, which is 28 degrees. We know we have the opposite side and we have the adjacent side. All right. So we're going to start opposite and adjacent. That's the tripping on apples. That's the TOA. So I'm going to start with tangent of my reference angle, 28 degrees, equals, and here's where things change a little bit. I'm going to show you. So I still set it up opposite over adjacent. So I've got 16 over x. And if you notice, this is different from my other examples, and the x is on the bottom now. This throws people off because, you know, they got, it's, oh, well, there's an x on the bottom. How do I get it by itself? I don't know how to get rid of 16. Well, you can't do it in one step. You got to do it in multiple steps. So what we're going to do is we're actually going to move x. And generally the rule is we don't move x unless we have to. But if x is on the bottom, then we have to. The way we move that, we saw that x was on the bottom. That means it's being divided. So we're dividing 16 by x. So we're going to multiply by x on both sides. What that does is makes that x go away, and we have x times the tangent of 28 degrees equals 16. Now, before, when we got here, we could just type that in our calculator and be done. But since x isn't a number we can type in our calculator, we need to do a little more work. So our goal is to get x by itself now. Well, we're multiplying x by the tangent of 28 degrees, right? So, since we're multiplying, we're going to divide to get rid of it. We're going to divide both sides. So what we're going to do is we're going to divide by the tangent of 28 degrees on both sides. So that cancels out. And I'm left with x equals 16 divided by the tangent of 28 degrees. Now I type this in my calculator. And what I do is I do 1/6 divided by tangent 28, close my parentheses, and hit enter. Alright, so again on all of these we round to 3 decimal places unless we're told to do otherwise, and we're not on this one. So we still follow that rule. We round that off, we get x equals 30.092, because again that third digit's a 6, or the fourth digit's a 6, so that helps us round up. So a lot of this is basic solving of equations, but just like all the other equations, you got to be able to set them up. That's the challenge. So on this one, we've got a reference angle of 50. That's always the first thing to do, find your reference angle of 50. And I have the side that's touching it, so that's the adjacent side, and I have the hypotenuse because it's across from the right angle. So I have adjacent and hypotenuse, that's the caught another hippie. So that's cosine of adjacent over hypotenuse. So I'm going to use the cosine of my reference angle, 50 degrees, equals adjacent over hypotenuse. So 6.4 over x. Again, this time I've got x on the bottom, so I'm going to have to move it. So what I'm going to do is I'm going to multiply by x on both sides. Those x's cancel out, and I'm now left with x times the cosine of 50 degrees equals 6.4. But I need x by itself, and it's not by itself yet. I've still got that cosine of 50 degrees. Remember what I said, anytime I've got sine, cosine, tangent, whatever I've got here, that's all one number. That is a number. If I punch in cosine of 50 degrees into my calculator, I get a number. It's a decimal. I will always have that as a number all by itself. So I'm going to move it all together. Never separate those. So I was multiplying over here. So I'm going to divide to get rid of it. I'm going to divide by what I want rid of. So cosine of 50 degrees. Divide by cosine of 50 degrees. So those go away. I'm left with x equals 6.4 over cosine of 50 degrees. Then again, just type that in your calculator. 6.4 divided by cosine 50, close your parentheses, enter. And you'll get that decimal out. You've pretty much got one of two scenarios every time when you're doing this, when you're setting up your trig ratios. And I always caution the saying every time, but with the basic setup there, you're either going to have a number on the bottom, like we did for our examples over here. So like here we had a number on the bottom and a number on the bottom, and you're going to multiply by that number and you'll be done, because then you can punch in your calculator. Or you'll have x on the bottom, you're going to multiply by x and then divide by your trig ratio. And it's pretty much always going to be one of those two scenarios. I'm going to do some more examples here if you want to follow along, but that's what we're doing today. So if you think you got it, you're welcome to dive in. I'm not going to do those other two examples over there because that's what we're doing tomorrow. And I'm going to move to my next slide here. I've got more practice with those. So again, if you're just getting stuck on how to set these up, I'm going through a couple more. I've got x is this side here. Here's my reference angle. Reference angle is always important. So I've got the opposite side and I have the adjacent side. Opposite and adjacent, I know I'm going to use tangent. Also know I'm going to use tangent because I don't have a hypotenuse labeled. So tangent of the reference angle, 28 degrees, equals opposite over adjacent. So 16 over x. I need that x by itself. So since it's on the bottom, I'm going to have to multiply by x. It's going to get rid of it on that side. So now I have x times tangent of my reference angle, 28 degrees, all over 16. Now I need to divide by what I want rid of, which in this case is the tangent of 28 degrees. Those are going to cancel out on that side. And I'm left with x over here equals 16 divided by the tangent of 28 degrees. And it's going to be, like I said, still following that setup. So let's look at this one here. I'm looking at my reference angle, 50 degrees. I've got the adjacent side, I've got the hypotenuse. So adjacent hypotenuse, call another hippie, that's cosine of my reference angle, 50 degrees. Adjacent over hypotenuse, so 6.4 over x. So just like I've done the other times that I have x on the bottom, I'm going to multiply by x to get rid of it on that side, because I need x by itself. That's going to leave me with x times cosine of 50 degrees equals 6.4. I'm going to divide by what I want rid of there, so divide by the cosine of 50 degrees. Those cancel out. I'm left with x equals 6.4 divided by the cosine of 50 degrees. Alright? Alright, so the first thing I gave you has this set up on there, and it's a lot of the same notes that we had in the video here. So there's no need to go through all that again unless you're just needing it, and that's a good reference for you at home. Ignore on this is right here where we're talking about solving for missing sides of a right triangle. When it talks about down here, talking about your standard entry, we do not have that on any of our calculators, so you can ignore that part and cross it out if you want to. It's gone, don't need it. So I promised you I'd do a couple of these. This first one, it doesn't even want you to solve. It doesn't want you to try to solve it all. It just wants you to label. So if you're not sure on labeling, feel free to rewind this, go backtrack on there and watch that labeling section again. But just doing a couple of them here, like one or two here, just seeing that. So I've got my reference angle, I have the opposite, I have the hypotenuse. So that's some old hippie, opposite over hypotenuse. So I'm going to use the sine. Sorry, we're going to use the sine ratio. And it wants us to label, so we've got opposite, we've got the hypotenuse, and we have adjacent. And that's all you have to do for that section. Over here, we got our reference angle, we've got the opposite, we got the adjacent, got the hypotenuse, and the two that they labeled for us are the opposite and adjacent, no hypotenuse, so that's going to be tangent. That's all I got to do for that first page. Alright. That next page, it's actually wanting you to solve. Want you to label the sides, choose the ratio and write it out, plug in and solve. If you choose not to label the sides, I'm not upset about that. You do what you want on that. If you're struggling figuring out what's what, that would probably help you to begin with. So I look at my reference angle, which is 41 degrees. I have the opposite side, the one that's not touching it, and the hypotenuse. So opposite over hypotenuse, some old hippie, so I use sine of my reference angle, which is 41 degrees, opposite over hypotenuse, so x over 6. And this one's one of the easier ones because the number's on the bottom, so when I multiply by 6 on each side, and I'm left with 6, sorry about that, 6 times the sine of 41 equals x. Alright, now all you gotta do is punch that in your calculator. So more of the same on those, just going through that setup, paying attention. We got sine, cosine, tangent. If you will look down here, you have some answer choices. Alright, it's wanting you to not bubble in the ones that are incorrect. They round to 2 decimal places. I said I would like 3. Okay, so I would like 3 unless you're told otherwise. If you notice up here in your directions, it does not tell you otherwise. It does have down here that's 2, but I'm telling you I want that 3rd decimal place. Alright, and this one, which is last but not least, which will not take you long at all, this one will be the quickest one. This whole sheet will probably take you 10 minutes. It just wants you to set up the ratio, and it tells you which one it wants you to use, and it tells you your reference angle. So we're using in reference to z. So tangent of z, that's tripping on apples. So TOA, tangent, so we're going to set this up, tangent of z equals opposite over adjacent, so 21 over 28. Alright, now do yourself a favor, punch that in the calculator and reduce it. You can get the decimal form if you want, but at least punch it in and reduce it. So you get the tangent of z equals both divisible by 7 gives me 3/4, or 0.75 if you really want. I do not need all three of those. Okay. I do need your initial setup, and I need one of those two. If you want to round to 3 decimal places if necessary, go for it. If you want to leave it as the simplified fraction that your calculator gave to you, that's fine too. But I need that initial setup, and I need the simplified one if it simplifies. Some of them may not. But that's all it wants you to do on that front part. It's just set up that ratio. Pay attention to your reference angle. On the back, do yourself a favor. Cross that one out. And cross this one out. Not worried about that. These guys down here, that's just punching your calculator. Sign 48, close your parentheses, enter. Give me the decimal to 3 decimal places. Notice up here you are given a different decimal to round to. It says 10 thousandths. For those of you that are bad at your decimal places, you never learn those. 10 thousandths is 4 decimal places. Alright? So you got to set up that ratio and solve on this one. Alright, I'm hoping that all of this together makes perfect sense even though I'm not there. I know that's kind of a lot to cover in one day. I'm sorry for that. You're welcome to go in Smart Lunch today. Remember, you do have Smart Lunch during B block. If you're wanting a review today, it's in Mr. Angle's classroom, talking about mid-segments. If you just need some time to work on stuff, you're welcome to go into any math teacher's classroom and work on your work for today. Any math teacher in the department will be glad to help you on trig ratios as well. You know, you don't have to be their student. They will help you even though you're my student, right? Hope this wasn't too bad for you. There's a very set formula, so it tends to be all right. And y'all have a great day.